Yeah, so this is my project, which is the cross-lingual transfer in Thulu legal comprehension. Okay, so I'll just start. Okay, so the problem is that a lot of models are trained in high resource languages, right? And those are like models, or those are languages where there's an extensive literary history and the means of training models on that literary history. Most of the world doesn't actually speak in a high resource language, and on top of that, especially in administrative and administrative processes and legal processes, people don't use those high resource languages. So how could a model understand any work being done in those places? For example, in the Indian state of Karnataka, people speak the language Kannada, and that's used in legal proceedings, in the courts, etc. But a secondary issue exists is that people under these administrative regions often speak a completely different language, unrelated from the administrative language, and a more lower resource than the administrative language, right? And so in a lot of regions of the Karnataka state, people speak the language Tulu, which is not represented in administrative processes, and people have to switch to a different language to get their legal needs heard. So how do we address this gap, right? So the question is, can minimal priming and Kannada legal papers alone let a model interpret complaints written in a language that it has never seen? And in that case, when I break down this question, it's that given queries or legal complaints in the Tulu language, can we give essentially small hints of the Tulu language and also use Kannada legal papers as a basis for models to reason and correctly categorize complaints? We don't want to build like a fully working large language model, but instead we just want to understand how comprehension works in these cross-lingual domains, and we're using the legal area as a really good place to ground this as an actual use that would be real life applicable. So the related work, one of the most important areas is context memory conflict, which is that when models have their own internal understanding of a situation, and external information can often sway how they process information after that. They can often defer to confidently stated information, even if it's wrong. And Llama 3 is especially like notorious of doing this. And related to that is RAG degradation, which is although RAG often helps the model, it can also hurt if it's noisy or when a model has to heavily depend on it, such as in low resource domains, where it doesn't really have a basis of its own and has to go off external information. And finally is the Tulu Kannada bridge, which is it's beginning to be used in the LLM field due to the fact of the extensive history between the two languages, and that is a really good grounded area of understanding multilingual transfer, and that there's already some preliminary evidence that large language models do parse Tulu as Kannada. So this would be it's like actually a very grounded experiment, right? Okay, so the methodology. So we wrote 60 Tulu complaints and used 18 Kannada court documents. So these are court documents written in Kannada script and often from lower courts. And then we used 4 query scripts. So for when we wrote the 60 complaints, we wrote them in 4 different scripts, which was um, Latin script, Kannada script, Tamil, and Malayalam. So the last 3 are all Dravidian languages, which is the same language family that Tulu falls under. And then the last we used 3 models, which was Llama 3, Hex 1, and Saravam. Llama 3 is not trained in Kannada at all, but has multilingual capabilities. And meanwhile, Hex 1 and Saravam are actually Indic models, so they are trained in Kannada extensively, but none of them are trained in Tulu. So the first step to make sure the experiment ran well was cleaning up the corpus, and a lot of the old documents were written in a different, like essentially script. So we had to rewrite them in a computer script essentially. So we had to rewrite them so that the Kannada Unicode was able to be used by the models, and then we had to type them with list categories. And a list category is essentially just a taxonomy for classifying legal situations, and we also use the list categories to classify every single complaint that we had written. And then the second was retrieval. So we had to, for the retrieval pipeline, we broke down all the documents into 800 character chunks and then embedded them along with the query sentences using multilingual E5 large instruct, which is an embedding model. And this is really useful because otherwise, since Tulu and Kannada are different languages, this multilingual model will be able to more accurately parse them. And then to ensure that we got the most accurate retrieved documents, we would use a cosine similarity to compare against court documents and the embedded sentence. And whichever one had the highest cosine similarity, we pick the top 3. We also, for the classification side, so this is how the model classified sentences, there was there were three aspects. The first was the primary, secondary, and tertiary. So the model could have three guesses: the primary one, which was essentially the main one, and then two other guesses, which were separate categories that it could ascribe to. The second was that we also asked for a reasoning trace verification. So it had to give a reason for why it chose the primary category. And then finally, we had a hits at 1 and hits at 3 score. So the hits at 1 score is if the model's primary guess also matched what we put as the primary category for the sentence, then that was a hits at 1 score. A hits at 3 score meant if the model didn't guess the primary category, but it was able to guess any of the secondary categories that we might have put for the sentence, then that was a hits at 3 score. And for diagnostics, how we would test and understand how the model comprehended the sentences. So we would also look at the trace verification, but also use statistical tests such as denominator checks and Fisher's exact test. Okay, so for the experimental design, we had 13 conditions, which were based across 3 axes. The first was understanding how script played a role in model comprehension. So again, that was the 4 scripts, which is again, Latin script, Kannada script, Tamil script, and Malayalam script. The second was priming. How would priming affect a model? And what I mean by priming is we would only give essentially a small little paragraph explaining the language with grammar and some basic words. And then finally, we would ask how RAG passages, how the inclusion of RAG and legal papers affected model performance. The priming itself could be broken down into 2 tiers. So every model which had priming had 2 types of priming. The first was just sparse priming. So that would be basic words like to go, to know. But then the extensive priming would give more detailed, would add on to that by giving more detailed words like how would it, like to like a court or to sign or a will, which would kind of give away the sentence. So what we're trying to see is how much priming is necessary for a model to understand language it has no basis in. And finally, we also had a few baselines so that we would use as essentially controls. So the first is the English translation one, and that was isolating how well a model performed when we give a high resource language in the query script, and this was isolating how simply how a low resource document, a RAG retrieved document, would affect that understanding. The second was the Romanized below in Kannada script without any priming in RAG at all. And this was isolating the internal or latent understanding a model might have in the low resource language. Okay, so on to the findings. The first one, which was really surprising, was that comprehension actually transfers without RAG at all. And that's that all 3 models were able to display a significant amount of comprehension in the low resource language that, again, that they had no training in without having major priming or RAG retrieved documents at all. And we also wanted to make sure this was just above chance. So we checked against random guessing and also majority class, which would be like if a model gets just the most common category in the entire complaints data set, and it beat both of them by a huge percentage. So the models were actually able to have this understanding the language. And but the really important thing to know is that this is only comparable in Kannada script. And when we use the Romanized script or we use Tamil and Malayalam, it didn't reach this level. So script is really important for a model to understand based on, and this is like reflecting previous findings by other people. And the second is we also checked against reasoning trace to see how the model comprehended. And for example, for Sarvam in condition H, which is again, no priming and no RAG, it was correctly able to identify the word court and then use that as a basis for reasoning, which again, we didn't teach at all. And then with sparse priming, it actually did help somewhat with Llama 3 and Hex 1, although not significantly, and actually did affect Sarvam negatively. So what we're trying to say is that there actually is latent understanding in models, even without any data, without any training. Okay, and second is that RAG collapses Llama 3. So to understand the picture, we have to first talk about Sarvam and Hex 1. In Sarvam and Hex 1, they were able to they're not able to fully understand, but what they were able to maintain their accuracy scores given retrieved documents. And so it's like if they were given just if they were given just priming, they were able to maintain that same score with RAG and priming. Meanwhile, Llama 3, its performance collapsed under RAG. And it's like you can see here with D, with full priming and RAG, it had a really low score. And that's reflective of it if it just only had RAG. These are like really similar scores, meaning that when we gave priming, it didn't really matter if we also gave RAG, and it deferred to the documents over its own understanding. But it does have a strong understanding, given that it's this really high score with just priming and no RAG at all. And And then also query language is really important, and I'll get to that in the next slide. Okay. So when RAG failed, how did it fail? So there were two separate mechanisms on how it could fail, which were across all three models, but specifically it was really common with Llama 3. And the first is fact substitution, which is that a really like small but often but wrong detail, but it could be a maybe marginally related to the query, but it wasn't really, right? And that would be actually included into the query and baked into it. And this new modified query was used as the basis for reasoning, and then obviously the model got it wrong. The second was confabulation, which is that the model would find a reason that existed neither in corpus nor query and use that again as a basis for reasoning and got it wrong. We also wanted to make sure that this wasn't due to label ablation. So because we would give the model, like along with the passage, we would give what label that passage fell under. So we removed that, but that didn't significantly affect model performance in Llama 3. And that we also wanted to check whether the RAG ever helped Llama 3, and it really didn't. And we finally, to check if there's any way as a preliminary mitigation step, we use a crack judge layer. And what this is, before any of the documents reached the call of Llama 3, we added a second call, which would independently verify every single passage retrieved and see if that was relevant to the query. And this is actually really interesting, because when the query was written in Kannada, it didn't help. But when it was written with an English translation, the model was actually able to start forming some form of discernment and accurately classified between or it didn't accurately classify, but it was able to classify at all. And when it was in Kannada script, it wasn't. So this is really important, because what we're saying is that a high resource language does give Llama 3 a scaffold to use and then to operate in a low resource domain, which may have already existed with Sarvam and Hex 1. Okay, and finally, when I was talking about latent knowledge and RAG robustness, you would think those are like two separate things, but they're really not. With Hex 1 and Sarvam, they had high performance with Kannada script, right? Which was already established as really important for a model to gain any form of understanding. And when we had written this, the queries in a Romanized script, then performance heavily failed in both Hex 1 and Sarvam. But they were able to maintain RAG robustness under Kannada script and priming and RAG. So what's important is that they were able to that the script performance affected them, but only when it was in English in a Latin script. Meanwhile, with Llama 3, when it failed with the Kannada script and RAG, it had similar scores as to if it had the Romanization script. And what I'm trying to say with this is that the RAG robustness and script advantage, they're related to each other. If a model is able to perform well under RAG, it probably is also able to maintain the script advantage that Kannada provides. But if it fails under RAG, then the script advantage disappears and it doesn't help the model anymore. Okay, so the conclusion is, so if there's anything to take away, it's that models actually do exhibit latent comprehension in low resource languages without any training. And this may be due to the fact that they already have training in a related language, or they exhibit multilingual abilities and are able to apply this to new languages. The second is that script is the lever. If we want to have models operate in low resource domains, we need to understand what scripts help them perform more accurately under such circumstances. And it seems that Kannada script, which is more lexically similar to Tulu than any other language, is very useful in that manner, and maybe this can be applied across all the other language pairs. And finally, that RAG is a liability, but it's heavily model dependent. If a model is trained in the language of the RAG corpus, then it's able to maintain the robustness even in a more confusing domain. But if it's not, then it needs a higher resource language to kind of anchor itself. For implications in future work is that something that's really important is that how a model performs with an unfamiliar corpus is actually not as dependent on the corpus as it is on how the model parses it. And second is that the evaluation methods used, such as reasoning trace and statistical honesty, seem to be viable and useful in other domains in these multilingual areas. And finally, if any future work wants to be done, it's probably going to be done with Dravidian transfer. So in the whole Dravidian family, larger data sets and stronger mitigation to understand if this effect is applicable across larger domains, and if there's any way to mitigate these effects. And finally, what would be really exciting if we can find any language pairs that, again, reflect these similar circumstances. But that's it. So thank you.